Write down. Conformational isomerism in N-butene. Tell me, what is N-butane? Which is contain 4 carbon atom and having normal chain, straight chain. Okay. Then when N-butane is rotated 1, 2, 3, 4, when it is rotated through the carbon-carbon single bond, that is C2 and C3, right? When N-butane is rotated through the second and third carbon, by rotating through second and third carbon, C2 and C3, C2 comma C3 carbon, so it forms again infinite number of conformational isomers, right? So out of n number of conformational isomers, there are 4 conformations are important. Tell me. 1, staggered conformation. Staggered conformation. 2, eclipsed conformation. 3, it is partially eclipsed. This eclipse is also called fully eclipsed. Fully eclipsed, partially eclipsed, and 4th one is gauche, or it is also called skew conformation. Right on. In N-butane, by rotating the molecule through C2 and C3 carbon, in N-butane, by rotating the molecule through C2 comma C3 carbon, it forms infinite number of conformational isomers. It forms infinite number of conformational isomers, out of which how many important? 4 are important. 1, staggered conformation. 2, eclipsed or fully eclipsed. 3, partially eclipsed. 4, gauche or skew conformation. Okay. Now let us see what are these 4 types of conformations. Right. So let me take first is staggered conformation. Right. Tell me, this is a front carbon and a back carbon. See, take it is a CH2, CH2, right? Now one carbon has 2 hydrogen, 1 methyl. No. Let me take front carbon. There is a 1 methyl group and there are how many? 2 hydrogen. And back carbon is, that is a cyclic ring is back carbon, 2 hydrogen and methyl. Tell me, it is which conformation? Staggered, because 2 methyl groups are opposite. No, this is called staggered conformation. Take down staggered conformation. Then when staggered conformation rotated 60 degrees, okay, by keeping this front carbon constant, then rotate the back carbon. So when you rotate the back carbon, let us take front carbon, it will be same, methyl, hydrogen, hydrogen. Then in back carbon, tell me, by rotating 60 degrees, where this methyl comes? Exactly behind this hydrogen, right? Behind the hydrogen, here H, tell me, here is H. It is nothing but eclipsed. Which eclipsed? Fully eclipsed or partially eclipsed? Fully eclipsed in the sense 2 methyl groups comes exactly one behind each other, and 2 hydrogen comes exactly one behind each other. Here 2 hydrogen, but all not, right? It is partially eclipsed. When partially eclipsed, again rotated 60 degrees, right side. So rotate the back carbon by keeping constant front carbon. So front carbon is a dotted dot is front carbon, and on front carbon hydrogen and hydrogen methyl will be in the same position. Now tell me, this methyl comes where? Middle, right? So this is methyl H. Tell me, which conformation? It is not a staggered. In staggered conformation, two methyls are opposite, two hydrogen opposite, all the hydrogen opposite. It is not a fully eclipsed, it is not a partially eclipsed. So in, no, right, see, in between staggered and eclipsed, that is a conformation, no, that is a skew, right? So therefore it is also called gauche. Next is rotate 60 degrees more, again right side. So there will be a front carbon, same methyl group, hydrogen, and back carbon. Methyl group comes exactly behind methyl group, and all the hydrogen comes exactly behind hydrogens. This is called fully eclipsed, nothing but eclipsed. Fully eclipsed. Then this fully eclipsed again rotate 60 degrees. What do you get? Methyl, hydrogen, same position, and back carbon methyl comes here. Now this is what? Again skew or gauche. Next, rotate 60 degrees more right side. Methyl, hydrogen. Tell me, now methyl comes in behind the hydrogen. It is partially eclipsed. Next, rotate another 60 degrees. What do you get? Staggered, right? You will get the first structure, right? It is a staggered conformation. Okay, now let me take, this is 1, 2, 3, 4, 5th, 6th. There are 7 structures will be formed by rotating every 60 degree right side. Okay. Now tell me, now I want, what is the order of stability? So order of stability is inversely proportional to energy. Okay, tell me, among this conformation, which is a most stable conformation? Staggered, right? 1 and 7. So staggered conformation is a most stable conformation because there is a minimum repulsion, right? Repulsions are minimum, almost nil. Therefore staggered is most stable. Next, after staggered, not eclipsed, no, not fully eclipsed, not partially eclipsed. You see the skew. In skew conformation, all groups are, they are actually not methyl opposite, but the away. Methyl groups are away from each other, hydrogens also away from each other. That's what they have minimum repulsion. So therefore gauche conformation is next. Okay, next is partially eclipsed. Next is fully eclipsed. So this is the order of stability of all these conformations. Okay. Then if I ask energy, what is the order of energy? So it is exactly opposite. So fully eclipsed has more energy, then partially eclipsed, then gauche, then staggered. Therefore, you can write one sentence: stability is inversely proportional to energy. Okay. Next is graph. When a graph is plotted between energy and rotation, let us take potential energy and rotation on x-axis. And now tell me, here first one is staggered conformation. No, let us take 0 rotation here. Okay, I will take rotation 60 degrees difference here, 60. Then tell me, next is 120, 180, next 240, next 300, no, 60, 300, next 360. Okay. Tell me now. So here energy. Now can you tell me whose energy is more? Now first tell me what is staggered. What is energy of staggered? Energy least, no? Means I'll take energy, this is a staggered. Next, after staggered, whose energy is more? Gauche. So I'll take here is somewhere here gauche. Next, after gauche, partially eclipsed. After partially eclipsed, let us take fully eclipsed. Okay. Tell me now. Now here staggered conformation. This is the energy of the gauche, partially eclipsed, fully eclipsed. Initially we have taken staggered, right? Staggered here. Next, by rotating 60 degrees here, which conformation you got? What is this? This is what? Partially? No. Okay. Now off at 60 degree, tell me. By rotating 60 degrees, what you got? Partial eclipse, no? Somewhere here, right? Next is after partial eclipse, what? Gauche, 120 gauche. Next is after gauche, 180 is fully eclipsed here, 180. Next, 240 is again gauche here. Next, 300 partially. Okay. 360 staggered again. This is no. Okay, somewhere here. So therefore, now we can plot the graph like this. Okay, tell me, this is a staggered. Here is partially eclipsed. Here is gauche. Here is fully eclipsed. Here is partially eclipsed. Here is staggered. Okay. So therefore, now tell me, in N-butane, which is a most stable conformation? Staggered. So what is the dihedral angle in staggered?
0.
No, the angle between two methyl groups. What is the angle between two methyl group in staggered? 180. Not methyl, two methyl groups are opposite. No, it is like this. It is 180. Okay. Next is conformational isomerism in beta substituted ethanol. Conformational isomerism in beta substituted ethanol. For example, let us take CH2, it is a X, CH2OH, it is alpha beta. So there is a beta substituted ethanol. This X may be X equal to, like it may be OH or electron, now more electronegative groups, OH, it may be NO2, it may be fluoride, chlorine, right, it may be aldehyde group, it may be keto group, something. Okay. Then on beta position, if there is a groups like OH, NO2, fluoride, chloride, then what happens and which conformation is most stable? Okay, let me take CH2OH. On beta position, there is a OH group. What is its conformation? Tell me. So to write the conformation, take the front carbon, right, and on front carbon, tell me, on this carbon there are two hydrogen and there is one OH. Next, back carbon. In rear carbon, beta carbon, there are two hydrogens and one OH. Okay, then tell me, if I write OH here, this H become, actually this is supposed to be most stable. Okay, in all the compounds, so this must be most stable because identical groups or bulky groups are opposite, there is no interaction. But if there is a beta substituted alcohol, OH group has to come on near to this OH group, because if they comes near to this, there is a hydrogen bonding is possible in between H and this OH. So due to hydrogen bonding, this structure become most stable, which is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding. So due to intramolecular hydrogen bonding, Gaussian is most stable in these compounds. Otherwise, usually staggered is most stable, but Gaussian become most stable because of intramolecular. Yes. So this is one exception. Remember, Gaussian is, take asterisk, Gaussian is most stable due to intramolecular hydrogen bonding. Then you may have doubt, intramolecular hydrogen bonding is also possible when hydrogen comes here, OH comes here, no, exactly behind like this eclipse. Still there is a more possibility of hydrogen bonding. होता नहीं, there is a, of course, lone pair will be there, lone pair will be there. If two OH comes exactly eclipse, one behind other, there is a more repulsion, there will be a more steric repulsions compared to this hydrogen bonding. That's what, they will not be like this. That's what, if they come like this, there is a minimum steric repulsion and maximum hydrogen bonding. Okay, so therefore Not only OH, if any group is present, there is a possibility of intramolecular hydrogen bonding and most stable. Conformational isomerism in cyclohexane. Conformational isomerism in cyclohexane. Okay, like similar to alkane, cycloalkanes, particularly cyclohexane, can also exhibit conformational isomerism. In the conformation of cyclohexane, cyclohexane has actually 4 conformations. One, boat conformation, half chair conformation, twisted chair conformation and chair conformation. There are 4 conformations of what? Cyclohexane. So out of 4 conformation, only one conformation is most stable. We will study that only. Okay. Therefore, cyclohexane exhibit 4 conformations. 1, boat conformation, it look like boat. 2, chair conformation, it looks like chair. And third, twisted boat. Twisted boat conformation. And fourth one is half chair conformation. There are 4 conformations of cyclohexane: boat, chair, twisted boat, half chair. But out of this, we will study about only chair conformation, not remaining all. We don't want actually. Okay, because this is the most stable. So out of this, chair conformation is most stable. Most stable, and it has least energy. Okay. Then what is the chair conformation? See, chair conformation can be written like this. This is the chair conformation. Okay. In chair conformation, see, there are how many? Of course, carbons are 6. There will be how many hydrogen? What is cyclohexane? C6H12, no? There are 12 hydrogen. Then, now where the 12 hydrogens are present? So remember, now each carbon has 2 hydrogen. This is the plane. The hydrogen which is present above the plane called axial hydrogen. Below the plane, which is called equatorial hydrogen. Therefore, cyclohexane has how many total hydrogen? Total 12 hydrogen. Out of 12 hydrogen, 6 are axial, 6 are equatorial. There are, okay, right on. Cyclohexane contain 12 hydrogens, in which 6 are axial and 6 are equatorial. Okay, then how to identify axial, equatorial? So usually axial, the meaning of axial is which is above the plane, no, not above the plane, which is, see, you can see like this. It is not always above the plane. It should be like this. It is axial. Now it comes above. It is equatorial. Now see, which is axial and equatorial is This is axial. It means it is based on the positions. If the hydrogen present in axial position along the axis, on axial position along the axis, it may be x or y z, any axis. Axial, equatorial, which is perpendicular to the axis. See, this is along the axis, axial. Like equatorial is equatorial. See, this is axial. So here equatorial is. So therefore there are total how many axial, equatorial? 6. Axial is along the axis, equatorial is perpendicular to the axis. Okay. Next, is conformations of monosubstituted cyclohexane. Conformations of monosubstituted cyclohexane. Not understood. You write first is cyclohexane like this. Like this. It is cyclohexane. It is called chair conformation. Looks like chair. ಅದೆಲ್ಲಿದೆ ಅಂತ ಕೇಳ್ಬೇಡ್ರಿ, ಅಲ್ಲೇ ಇರುತ್ತೆ, ಅದರಲ್ಲಿ ನೋಡ್ಬೇಕು ಹಂಗೆ. Right? See, now first I'll write axial. See, this is one axial, 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 along the axial, axial, this is axial, this is axial. So all these are axial bonds. They are along the axis. That is denoted by HA, 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 HA. Then equatorial. So equatorial, they are actually perpendicular. HE, okay, HE, HE, this HE like this. HE, 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 HE. Okay. Now tell me conformations of monosubstituted cycloalkane. Now, if the cycloalkane contain one substituent, that one substituent may be present at axial position, it may be present at equatorial position. For us important is which is most stable. Dhanush. So if if a substituent present at axial position, what happened? Equatorial position, what happened? So this is you have not studied in your PU level. Try to understand. Tell me. Suppose, let me take if it is a axial position. If the substituent present at axial position here, okay, I'll take this is one substituent. Instead of hydrogen, I'll take methyl group. Okay. If the substituent present at any axial position, this axial position is interaction with it is 1, 2, 3, 4, 5, 6. It has interaction with which axial positions? This is called 1 and 3. 1 and 3 axial positions are comes closer, and even 4 and 1 and 5. So therefore there are two type of interaction. That is a 1,3 interaction will be there, and 1,5 interaction will be there when substituent present at axial position. Okay. Now let's see another option. When the substituent present at equatorial position, if it is at equatorial position, you can take any equatorial position. Okay. If it is comes on equatorial position, this equatorial position has no interaction with any other. It looks it is coming near, but 3D structure. Okay. If it goes like this down, it goes something different way. Okay. So therefore this methyl group is do not have interaction with any other positions. Therefore, now question is, if one methyl group is present or one substituent is present on cyclohexane, where it's supposed to be, where it should be present? Axial. Why? Why axial? If it is present at axial position, it has interaction, no? Irbeka irbadu interaction. Irbadu tane? Irbeka. If there is a interaction, repulsion, no, interaction means repulsion. There is a repulsion between this methyl group hydrogen. Due to repulsion, this methyl group is unable to, have stability. Therefore, it automatically goes to axial, where? Equatorial. So therefore, if one alkyl group or one substituent present on cyclohexane, it must be present at equatorial position to get the stability, not axial position, right? Therefore, tell me, in case of monosubstituted cyclohexane, take this. This is 1, 2, 3, 4, 5, 6. There is a hydrogen here, and a fifth hydrogen comes here, right? Therefore, 1 comma, if write on methyl group present at axial position, if methyl group present at axial position, it has repulsions from, which axial? 3 and 4, 3 and 5 axial hydrogens. 3 and 5 axial hydrogens. But if it is present at equatorial position, it do not have any interaction, from other hydrogen. Therefore, methyl group present at equatorial position is, more stable than what? Axial position. Okay. Next, that is the conformations of monosubstituted. Let's see one more. Conformations of disubstituted cyclohexane. Conformations of disubstituted cyclohexane, right? So conformations of disubstituted cyclohexane. Tell me now let us take cyclohexane chair conformation. Okay, in disubstitution may be like 1-1. That means 2 substituent may be present on same carbon, or 2 substituent may be present on different carbon. Let's say case 1, if 2 substituent present on same carbon, if 2 substituents present on same carbon atom. Okay, come on, tell me, if the two substituent present on same carbon, where they have to present? Oh, there is a two positions, no, one is axial, other should be a equatorial. So if there is a one group is on axial position, something here is, take methyl, okay, other should be what? Equatorial. It is something X, like that. But again there is a difference. Difference is, if the methyl group, X group, both are same, if both are identical group, there is no problem. One, because one is axial, other should be equatorial. But if there are two groups are different, one is a smaller group, another one is a bulky group. Like take, it is a methyl, it is ethyl, one propyl, one methyl. If the two groups are different, tell me where the bulky group should be present, where the smaller group present? Bulky group should be present on equatorial position, because it experience less repulsions, means no repulsion. And smaller group should be present on axial position, because when smaller group present on axial position, it has little less interaction compared to bulky group. If there is a bulky group here, it's already bulky, means big in size, larger in size, it has more interaction with this group, it become highly unstable, right? Therefore, if the small group, one is axial, one is equatorial. If it is large group like methyl, it should be something ethyl. So ethyl group should be present on equatorial, and methyl group should be present on axial. Okay, right on. If two substance present on same carbon, first case, two substituent present on same carbon. Okay, right on. If the two substituents are similar, one is present on axial position and another is present on equatorial position. One is present on axial and another present equatorial. Next point, if the two substituents are different, smaller substituent should be present. Smaller substituent should be present where? On axial position. Smaller substituent should be present on axial position, and larger substituent or bulky substituent should be on equatorial position. Okay, example, if two substituents present on different carbon atoms, if two substituent present on different carbon atom, tell me, if the two substituent present on different carbon atom, they should be present on which position? They must be equatorial positions, right? Right. They must be present on equatorial positions only. They must be present on equatorial positions. Like one is a equatorial, this is also equatorial. Okay, next, identification of cis trans isomerism in cyclohexane. cis trans isomerism in cyclohexane. Right. So identification of cis and trans isomerism or isomers in cyclohexane. Right. This is we have studied in cyclohexane. If one group is below the plane, okay, another hydrogen and methyl, this is hydrogen, methyl, here something OH. Tell me, cis or trans? If identical groups are same side cis, opposite side trans, this is a cis. We have studied this. Okay, now let us take chair conformation. Cyclohexane has how many conformation? 4, no? All 4 conformations are called packed conformation. We have, I told somewhere. Cyclohexane has 4 conformations. Out of 4 conformations, this is chair is most stable, but those 4 conformations all together called packed conformations. Okay, it's not required, just remember one word. Okay, fine. This is, now tell me, if identical groups are present on same side, for example methyl and methyl, tell me, cis or trans? How? So here, no, both are axial, not that way. See, axial, equatorial, that concept is different. Cis trans is completely based on what? Whether identical group of same side cis, opposite side trans. Then you need to see whether identical groups comes same or opposite side. How? You take the plane, this is the plane, okay. So this methyl present above the plane, this methyl present below the plane, above the plane, below the plane, this is a trans. It means not axial cis, okay. Let it be axial, but how the bonds are present, whether above the plane, below the plane, means one side. So above the plane, it is below the plane, trans. For example, one more. Let us take, it is a chlorine and this is chlorine. It is cis. Why? It is above the plane, it is also above the plane. It means, now tell me, now this is 1, 2, right? 1, 2, axial, axial. So can I say like this, 1, 2, axial, cis or trans? Trans. Okay, next, it is also 1, 2. 1, 2, axial, equatorial is what? Cis. Do you understand? By giving this, no, they may ask which of the following cis trans. Structure will be like this, 1, 2 AA and 1, 2 AE. So you need to identify the cis trans. It means by drawing the structure. Do you understand? Like one similar question. Do you understand? One more. For example, take this chair conformation. It is a bromine is here, right? Here is bromine. Cis or trans? Trans. Above the plane, below the plane. Therefore, this is 1, 2, 3, 4. It is 1, 4. This is axial. It is axial. So A, A. That is trans. Trans, no? Trans. In question, they expect they will give this 1, 4 AA. Cis or trans? Then write the structure, identify. Okay. So write on question. Identify the cis and trans isomers in the following. Identify the cis, trans isomers in following. 1. Tell me, first one. Tell me which it is, which confirmation it is. 1, 3, A, E. Cis or trans? Trans. Next. 1, 2, E, A. Huh? Cis. Next. 1, 3, A, A. No? Below the plane, cis tane? Cis. Hey. It is 1, 2, 3. 1, 3. Axial. Both are axial, no? Below the plane. Cis. Alright, 1, 3, AA, always cis. 1, 2, 3. 1, 3, A, E. Above the plane, below the plane. Trans. So 1, 3, AA, cis. 1, 3, AE, trans. You need not to by heart. Remember the concept enough. 1, 3, E, E. Cis. Because A, A. 1, 3, AA, cis. 1, 3, E also cis. A is AE, EA, trans. Like that. Okay, so optical, no, all the isomerism is completed, right? Tell me, in isomerism topic, so far what you have completed? Structural over. So structural isomerism further classified into 6 types. 1, chain isomerism, positional isomerism, functional isomerism, ring chain isomerism, metamerism, tautomerism. Okay. But among this, the most very important is tautomerism. There will be a many question, even expect in final exam also, tomorrow exam also, question can be expected. Tautomerism mele. Then others are simple question, which are geometrical, which are like positional, which are chain, which are tautomers, like which are metamers, this kind of questions. Okay. Next is stereoisomerism. Stereoisomerism further classified into 2 types. Conformational, configurational. First we have studied configuration isomer. Okay. So what is the configuration? The spatial arrangement of atoms or groups around the symmetric carbon is called spatial arrangement. Right. Then, that is configuration. Then configuration further classified into 2 types. Geometrical, optical. Okay. Geometrical also important. Which can exhibit geometrical, which cannot exhibit geometrical. Right, which can exhibit cis trans, which cannot exhibit cis trans isomerism. Okay, there. So which compounds can exhibit geometrical isomerism? 1. Alkene. 2. Oxime. 3. Diazo compounds. 4. Cycloalkanes. 5. Conjugated dienes or conjugated enes, polyenes also. Next is cumins, cumulated enes, cumins. Cumins also called alkenes, alkenes. Okay, then condition. First condition is carbon carbon double bond, means not only carbon carbon, carbon nitrogen, nitrogen nitrogen, there should be a double bond. Okay, because there is a restricted rotation around the carbon carbon double bond. Even carbon carbon single bond also possible, but there should be a cyclic ring. If there is a cyclic ring, there is a restricted rotation. Rotation is not possible through the carbon carbon single bond in cyclic ring, but it is an open chain, that is possible. Rotation is possible. That's what here not possible geometrical, here possible. Okay, then all example there you can remember examples. Okay, next is their calculation. One important concept is calculation of number of geometrical isomers. Okay, in polyenes, right? In polyenes, how do you calculate geometrical isomers? There are two conditions. One, terminal carbon atom attached to same group, different group. First different, then same. If different group, 2 to the power n. If they same group, again there are two conditions. One, even number of double bonds, odd number of double bonds. You remember the formula and calculation become easy. Okay, then next is optical isomerism you have studied, right? In optical isomerism, the most expected questions are like this: which can exhibit, which cannot exhibit. Okay, so ella ostu odidrunu ade concept baradu finally, which exhibit, which cannot exhibit optical isomerism. So to understand that you need to study all. Okay, there, which can exhibit optical isomerism, how to identify and optical isomers. So first condition is if any molecule having only one chiral carbon atom which is optically active. If it has 2 or more chiral carbon atom, we need to see plane of symmetry. Okay, yeah, that is condition is chirality. So to understand chirality, we have 3 elements of symmetry. You need not to bother about 3. You just see only plane of symmetry. If any molecule having plane of symmetry, do not exhibit, like mesotartaric acid. Okay, in our syllabus we have only plane of symmetry discussion. Okay, the only definitions are there, you need not to bother about that. Okay, that's how you can identify which can exhibit, which cannot exhibit. Other than this, there are some molecule do not have even chiral carbon, they exhibit optical isomerism due to presence of chiral axis. They have chiral axis. Then 1, alkenes, 2, spiranes, 3, cycloalkylides, 4, biphenyls. Okay, what are the conditions and all you remember. So adar mele question bandide, you can expect question even in our exam also. Okay, next is conformational isomerism. In conformational isomerism, this week I have not given question from this, it will be there next week, from conformation onwards next week, but study now only. So what are conformational isomers and example? Conformational isomer is the isomers which are formed by the rotation of carbon carbon single bond. By rotation of carbon carbon single bond, you will get n number of conformation isomers, right? So out of n number, so which are important and importance? If you take ethane, there are only 2 are important: eclipse, staggered. In eclipse staggered, again important is energy and dihedral angle. Energy of eclipse is more compared to staggered. Stability of staggered is more compared to eclipse. Then what is the dihedral angle? Trans is 0, cis is 60. Then n-butane. In n-butane has 4 important conformations. 1, staggered, eclipse, partially eclipsed and skew, that is Gauche, right? So all the structures, their energies and relative. And next is this conformational isomerism of cyclohexane. Okay, okay, next is reaction mechanism. We'll continue next off.